Hey there. Today we are going to talk about a topic near and dear to my heart, web dev and React. I recently came across this YouTube video from Theo, T3.gg, titled "Why is every React site so slow?" And it is a great video whether you are a beginner React developer or a seasoned React developer. Highly recommend that you take a look at it. Theo gives a really great breakdown of some of the challenges and what's really happening under the hood when we say React re-renders. Okay, now this is a great video, but what Theo doesn't really point out is that React's model of reactivity is actually completely inverted from every other library and framework that's out there, including vanilla.js. So what I want to do in this video is take you through some really simple examples, which I'll include in the links below, of how you can think about React's reactivity model and why it's completely inverted, okay? So first, let's take a look at what this would look like in vanilla.js. So in vanilla.js, we have this really simple example. We have a label and an input here, right? And what we're going to do is we're going to grab references to these two elements. We're going to allocate a date instance with now. We're going to log that we're rendering. And then we're going to connect this event listener to update this label when we start typing, okay? So let's run this example. So you can see right away we have our rendering, which means that this allocation of the now occurred. As I start typing, keep your eye out on this time here and also the log console on the bottom. Okay, so a couple of things you'll notice is this time doesn't change. The other thing you'll notice is this rendering only gets executed once. Of course, this makes total sense, right? This code only executes one time. This path of code only executes one time. On the key up, the reactive piece of code is only encapsulated in this callback. That's it. This is how vanilla.js works, right? We don't expect that all of this code is going to re-execute, so it's perfectly fine to allocate this date out here, and it's perfectly fine to do this here or even add another function here. We can be assured that the allocation only occurs once, okay? Now, let's take a look. What if we rewrite this as a JavaScript web component? So I've got the same thing here. It's a simple web component. And what we're going to do is we're going to just grab this template here with the label and the input, and then we're going to attach it to the main DOM. And as we attach it to the DOM, we're going to do the exact same thing. We're going to add an event listener and bind a function so that on key up, we're going to update the user interface. So let's run this and see. We can see here, we have our call to rendering right here in the constructor. And let's start typing. Okay, you can see the time stays stable. Our rendering only gets called once because, of course, as we expect, this code here only executes one time. And the only code that's executing reactively to the event in the UI is this code here. That's it, right? Our allocation of the now only occurs this one time, okay? Now, let's take a look at a framework like Vue. And in Vue, we have in our Vue example here, we have a custom component. We have a reactive variable here for the name. We have a non-reactive variable for now that we've allocated. We're going to log that we've started rendering, and then we're going to create this reactive watcher on the name so that when the value changes, we're going to log it out, okay? And then we have our simple template here. So if we run this, we'll see we have our call to rendering, and if we start typing, okay, you can see our time is stable, and our rendering only gets called once, which means this allocation only occurs one time as well. The only code that's executing reactively is this block of code, and that's it. None of this other code that's here is executing again on these changes. So Vue is based off of a signals-based paradigm using proxies. On the other hand, here, we're just using event listeners, right? Now, React, as you might have guessed, is the only one that is completely different, okay? So let's take a look at what's happening in React. So in React, we have our component function here, and our component function is going to do the same thing. We're going to log that we're rendering, we're going to allocate our now, we're going to define this use effect here, okay, so that we can log the name or execute other effects here, and then we have our template. On the surface, this looks a lot like what we have here, right? There's not that different, right? You would kind of expect this view.watch to behave kind of like this use effect. But in fact, they are actually completely inverted, and we'll talk about that in a moment. So let's take a look. I'm going to run this example. You can see we have our rendering just like the other examples. But as I start typing, you'll notice a couple things. One, the time is changing. And then two, of course, this rendering is being called again. So what's actually happening? Let's think about this, right? What's really clear here is that all of this code is being executed again. So in every other example that we've looked at, the unit of reactivity is actually a callback, right? So in the vanilla.js example, the callback is this particular function, right? In this web component example, it's this function. In Vue, it's this anonymous function here, right? In React, you would think that actually the only reactive code should be this code here. But that's actually not the case. Actually, this whole block of code is being re-executed, right? In fact, you can think of it like this, is that in every other model, okay, you are opting in, you are explicitly opting in to reactive changes, right? So here we're explicitly connecting an add event listener and saying only execute this function on your reactively on your updates, right? Here, the same thing, only execute this function reactively on your updates. And here it's exactly the same. We're only going to execute this code reactively on updates. In React, it's actually completely different. We actually have to take the non-reactive pieces of code out from the path of the component function. So how do we do that? That's actually what hooks are doing. So let's take an example here. If we use memo here, okay, now if we run this example, let's clear the console and run this example, okay? Keep an eye on our time, okay? Okay, now our time is stable, but our rendering here is still being called, right? Which shows us that we're still coming through this full block of code. What's actually happening is you can think of it conceptually like we are taking this value, okay? We are actually taking this value out from the path of this component function, and then we're putting it back in when it gets executed again. So we've taken it out, and when it executes again, now gets allocated the same exact value that was here before, okay? On the other hand, here, this code never executes again, okay? So React, Vue, JavaScript have completely inverted models of their reactivity, okay? And I think a lot of folks don't realize this when they're, especially if you started out writing React and you didn't start out writing JavaScript, or you haven't tried other frameworks like Solid or Vue or Svelte, right? You may not realize that actually all of the code that you have in your component function, whatever allocations you have here are going to be reallocated and re-executed again. So for example, if I declare a function, foo here, right? This function foo is going to be reallocated every single time that the component updates. And this is one of the reasons why it's really easy to get into performance issues with React, because if you don't really think about where and how you're placing your code, a lot of allocations are going to happen on re-renders, right? Especially for a big application. And a lot of times, a lot of funky behavior happens because, if you don't realize that you need to memoize this value here and you actually need to pin the value of now, right? Let's say we actually do need this value to be pinned. You have to kind of consciously think about, okay, I need to memoize this value if I have a dependency, or for example, I can move this value out because in this case, I have no dependencies, right? So I can just put the value up here instead, right? In React, you really have to think about where am I putting all of my state and all of the things that I don't want to be reallocated or recreated when my component re-executes. And I think this actually creates a sort of a mental burden that a lot of people don't really think about. To some extent, I think the new React compiler that's coming out, there's a really great, Theo mentions it, but there's a really great article by an author on Medium that I will post down below that I recommend everybody check it out because it's a really great explanation of how the compiler addresses this issue and the edge cases that might still leak out, right? But the fact of the matter is that's kind of like putting a Band-Aid, in my opinion. It's kind of like putting a Band-Aid on a self-inflicted wound, right? There's really no reason that React couldn't, for example, just make just this part reactive, right? It looks, this part here, the funny thing is this code here looks just like this code here, right? It's almost identical, right? But the difference is that in Vue, only this code is going to be executed reactively. And in React, that's not the case. It looks like it, but that's not the case. All of this code is being re-executed, right? If React were to adopt a signals-based paradigm, it could be possible, right? That only this code is going to be re-executed because, there was a change in one of the dependencies. Okay, now I'm going to execute just this code and I already have the template, so why don't I just take the template and update just this piece of code, right? I think this is a really important aspect of React that folks don't necessarily think about is just how different it is from every other framework or library that's out there, including vanilla.js. And I think if you're like me, if you come from a background where you did a lot of JavaScript and HTML and web applications before React existed, right? Or if you worked with frameworks like Knockout.js, for example, right? Then React always feels a little bit off in some way. And the reason why it feels off is actually really simple, right? Its model of reactivity is completely inverted from everything else that came before, okay? So I hope this short video was helpful to helping you understand React's model of reactivity, and hopefully it'll help you write better, more performant, less buggy code in the future.